first of all, let me ask you guys some questions. Then we'll start because this is the last chapter ORG. है ना? So this is your carbon and its compound. So this we will complete. First of all, let me ask you some questions. So that did like I've already discussed no? That chemical properties of elements. So how many reactions are there for this chemical properties of elements? Yes, Safia. First, you tell me.
Yes, ma'am, can you repeat?
So, chemical properties of metals. This thing is there, no? Chemical properties of metals. So, first reaction is what? That reaction of metals and oxygen. So, you have to tell me the chemical equation. What is the chemical equation of this reaction? That what two thing will get added and what product will get?
Metals react with oxygen to form metal
Hmm.
oxides.
Okay, metal forms oxygen to form metal oxide. Good. Next question to this is also same. Your metal is combining with your oxygen to forming a copper oxide. Where's the next one? And these two are what? These two are alkalis. And this is what? That exceptions of your metal oxides is how many exceptions? Two metals are exception now. Tell me about those two.
Um,
Yes, Rosh. Hmm.
Aluminum and zinc are the exceptions because they're not basic in nature. They're amphoteric and they act as both basics. Uh, I'm sorry, they act as both bases and acids.
Good. And now anybody tell me the reactivity series. This one. So first, Rudri, you tell me.
Ma'am, potassium,
Oh, walaikum salam. Okay, potassium,
sodium,
sodium.
calcium.
Just a second, Rudri. Yes, Shazan.
Ma'am, mix water addition.
Okay. Just a minute, Rudra. See, this is the last chapter, the organic carbon and its compound. This chapter is already completed. Your MET means metals and non-metals.
Yes,
I'm
ma'am.
only just revising this chapter.
Okay.
Okay, Shazan, you know this, na, that physical property of metal is in
Yeah.
ninth class also this thing is there that metal should be lustrous, metal is hard, ductile, malleable, metal conducts electricity, and the melting and boiling point of metal is high as compared to
Okay.
the non-metals.
Yes, ma'am.
Okay, and this is what, and how were you, Shazan? Where were you? Like,
Ma'am, like
hmm,
I
hmm,
wasn't attending class in between. I was in
hmm,
hospital, but now
strong.
I'm okay.
Okay, from 1 month. Okay, so this is what? This is the chemical properties of metal. Shazan, see. This is what? Here, your metal will react with your oxygen to form a metal oxide. Okay, any metal like
This I know. This
aluminium,
I know.
this you know. Okay. Now next. Next is this. Only two are the exceptions of your metals. First one is your zinc, and another one is your aluminium, which shows acidic and basic behavior.
I
And
have taught this one. I was there in the class.
Acha, you was there. Okay. So the reactivity series,
Yes, ma'am.
I
Yeah,
think
that's one, that's one.
all everybody knows, है ना? Potassium, sodium, calcium, magnesium, aluminum, these. And before and up of your hydrogen, all are what? Most reactive, and below of this hydrogen, all are least reactive. Okay?
Yes,
So
ma'am.
this was the main part that here, this is your first two potassium and sodium. These are the most reactive. They react with your cold water and they are very exothermic. Okay, means when they react. So here, let's say this is beaker and this is what? This is the chemical reaction that in this beaker I am mixing potassium with water, which will form your potassium hydroxide and H2. H2 means hydrogen gas will evolve. So in your environment, oxygen is present. So hydrogen gas will combine with your oxygen and large amount of heat will evolve. Okay. So your this potassium and your sodium also catches fire. And if they will catch fire, your potassium will turn into purple and your sodium will turn into a yellow flame. Now, what is next? These two will react with a cold water. Your magnesium will react with hot water. And these three, your aluminium, zinc, and iron, will react with your steam. And these are not so violent as compared to your first two. Okay, this I've already discussed. See, Mg is what? And what about magnesium? Magnesium will not react with your steam. It will not react with your cold water. It will not steam nor cold water. And what about this one? This is the main that here see your aluminium is combining with water to form this aluminium oxide and hydrogen gas. Zinc is also ions also, but this reaction is a reversible reaction. And here your ZNO will form, will turn into yellow if it will combine with a hot water, and this will turn into white if it will combine with a cold water. Okay, next is reaction of metals with water. So this is the reaction. If we will mix metal with water, we will get metal oxide and some hydrogen gas. Here, for example, if I'm mixing potassium, sorry, if I'm mixing here potassium and your cold water, so we will get potassium hydroxide and hydrogen gas. Now, you guys tell me this reaction. If I'll mix with nitrogen and with, no, not this, this is the balancing one. If I'm mixing sodium with water, what will I get? This is the question. Now, you guys tell me. Solve and tell. This is the reaction of what? This is the reaction of metals with water. Okay. So this will form your metal oxide and your sodium hydroxide plus hydrogen. Yes, sodium hydroxide plus hydrogen and some amount of heat. Okay. Next is what? This is your calcium. This we already know, means it will combine with same process. It will combine with your cool water, calcium hydroxide, and your hydrogen. These two are also same, and this is just showing the reactivity series, that which element is more reactive, sorry, which metal is more reactive and which is not. Next is what? Next was your reaction of metals with acids. So if I will mix your metal with acid, it will form salt and your hydrogen. So here, what is the main thing you need to know, that if metal will react with any kind of acid, it will form salt and water, but only two types of acid is involved here, your H2SO4 and your HCl. We will never we will never react metal with HNO3, but two elements are there, which are manganese and magnesium, which will react with HNO3. So these two are exceptions, but for all other, we will only react with the with this one or with this one. Okay, so
Yes, ma'am.
here if I'm so here if I'm reacting the zinc with this H2SO4, Roshni, you are getting it now? Okay, any doubt you can ask, huh? So here if zinc is reacting with your H2SO4, it will form your ZnSO4 and your hydrogen gas. Here, see, I'm combining with H2SO4 and I'm combining with HCl. I'm not combining with HNO3. So aluminium with hydrochloric acid, this thing, and your hydrogen gas. This is your reactivity series. This you already know. And here, why this reaction will not happen? Anybody know? Shazan, do you know why copper plus HCl, diluted hydrochloric acid, will not form any reaction? Why?
Ma'am, no
Any?
idea.
No idea? Okay. Rudra, do you have any idea that why this reaction is not? Huh?
No, ma'am.
No. Okay. Safiya?
Because in the reactivity series, the copper falls below hydrogen and
Yes.
it's
Very.
not able to displace it.
Yes, good. Why? Because see, where's copper? Copper is here now after your hydrogen. So these will never react with your HCl or with your H2SO4, because these are what? These are less reactive. So if I'm writing here Hg, mercury with dilute anything like dilute HCl or dilute H2S, sorry, HNO3, it will not form any reaction because these these were less reactive. Now, what is the next one? Huh? Only these two will react with your that HNO3. So here, if let's say manganese is reacting, so it will form your magnesium nitrate and your H2 gas will evolve. Okay, so next is what? This is the reactivity series. We already know this. Next is your non-metal. Non-metal is having the property of malleability and ductility, that non-metals are neither malleable and nor ductile. What is brittleness? Non-metals are brittle in nature. For instance, sulfur is a brittle solid. If it is hampered, it breaks into pieces. If you'll hamper the sulfur, then what will happen? It will break into the tiny pieces. Physical state. So only diamond is the hardest substance and which is non-metal. What about luster? They do not have this luster property also. So now you can relate now with a metal and what is metal, what is the physical property of metal and what is the physical property of non-metal. Yeah, okay. Next is, this is also 2 points, that your non-metal do not conduct electricity, is a poor conductor of heat and electricity. And what is the melting and boiling point of a non-metal? The melting and boiling point is very low. And but non-metal are that are solids have comparatively high boiling points. These three will have the high boiling point. Now, so there we already discussed the chemical properties of metals, metals combining with acids, with water, forming metal oxide. So here we will see some of the chemical properties of non-metals. So what are they? They are that non-metals do not react with water, steam, or dilute acids to evolve hydrogen gas. They were reacting with water, na, with steam, and you dilute acids to evolve your hydrogen gas. But here non-metals do not react with this, or this. The reason is that they act as an electron acceptor and cannot supply electrons to the H plus ions of acids to reduce them to the hydrogen gas. What is the reason? That they cannot supply your H2, H plus ions, they cannot supply this ions. So that's why if they'll not supply any of the ions, then what will happen? They will not, means then hydrogen gas will not evolve. That's why this your non-metal category will not evolve your hydrogen gas. But on heating, readily form oxides or salts with concentrated acids. Now see, here is what? Here is your sulfur. Sulfur is combining with your H2SO4. So it will form your SO2 and hydrogen, sorry, and your water. See, here your hydrogen gas is not there now because it cannot supply the electrons to your H plus ions. That's why your hydrogen gas will not be there in your non-metal thing. Here also you see your chlorine. This is the displacement reaction. We already know what is a displacement reaction, that the most reactive element will displace a less reactive element. So here chlorine and sodium bromide. Now what is happening? Bromine is there. So your Cl is more reactive or bromine is more reactive? Tell me. Cl is coming first in the reactivity series or just Br? Any idea? Nobody?
No.
Okay. Anyone? Safia. So we will check. This is a reactivity series. Now see. There was a calcium. So calcium is coming first. Then what will happen? Your calcium will, sorry, the chlorine is there. Na? So chlorine will combine with your, means chlorine and sodium is there. So what will happen? Your salt will, where is it? Yes, see. But on heating, it will form oxides or salt. So if this chlorine will combine with your sodium, then it will form your salt, because in the product thing, what we want? We want salts or we want any kind of oxides. Okay, now what is next? Next is your this reaction between the metals and non-metals. So you all know now that electronic configuration thing, KLMN. Okay, so I'll ask you one question, that for sodium, what is the atomic number of sodium? Anybody? Nobody knows. Shazan, you also don't know what is the atomic number of sodium?
Ma'am, I know.
So tell no.
It's written in my note.
Huh?
Ma'am, it's written in
God.
my.
Okay. Roshni?
Ma'am, it's 11.
No, ma'am, it's not 11. Ma'am,
What?
it's 23. It's 23.
I'm asking about atomic number, not mass number. Okay.
Ma'am.
So atomic number is 11. Now how to fill orbit? This is, let's say this is my K, L, M. So what is the electronic configuration of the sodium? Tell me. What is the electronic configuration of the sodium? It's easy.
Ma'am, it's 281. 281.
Yes. 2, 8, and 1. Because 10 and 1, 11. So here, this is the K orbit, K shell. So here there will be your 2 electrons. This one is your 8 electrons, and here will be your 1 electron. Okay, if let's say this is my one of the orbit, just random orbit, and if I'm drawing here 7 electrons. So this you already know na, that outermost orbit needs 8 electrons, means it should complete its octet. Octet is very necessary for the outermost shell or outermost orbit. Now you tell me, here is how much? 1, 2, 3, 4, 7 electrons. So how this orbit will get total 8 electrons? It will gain 1 electron, or it will lose all 7 electrons. What will happen? It will gain or it will lose all 7? Because losing 7 is also okay and gaining 1 is also okay. But what is the simplest method? Gaining 1 or losing 7? Nobody knows?
I'm gaining 1 electron is more easier.
Gaining one electron is more easier. So what will happen? It will gain one electron. That's it. So here is what. See, each element wants to have completely filled valence shell. It wants to have either 2 or 8 electron in its outermost shell. But 8 is must. It needs to complete its octet. So there is what that metals have a tendency to lose electron to form cations. Metal is having a tendency to lose electron to form what? Cations. And what about non-metals? Non-metal is having a tendency to gain electron and to form an anion. To gain electron to form what? Anion. Now, and what is your cation? Cation means your positive ions. Cation means your positive ions. And your anion means your negative ions. Okay. So what will happen? Metal will lose electron to form cation, which is positive ions. A non-metal will gain electron to form anion. And what is anion? Anion is your negative ions. So here, as you can see that when metals and non-metals react with each other, they tries to complete its outermost shell. So this is the electronic configuration of sodium, which is 281. This is the electronic configuration of sodium, chlorine, because the atomic number of chlorine is 17. Okay. So here, see, we found that it is easier for chlorine to gain one electron in its M shell rather than losing seven. Okay, now you got to know that it is easier that sodium needs to gain one electron than losing this seven, because it has a tendency to gain electron to have a completely filled outermost orbit, because each shell wants to complete its outermost orbit, whether they can gain, whether they can lose, or whether they can share electrons. Now this is what this is your sodium, which is 281. Now see, in the outermost orbit, there is only one electron because it is 281. Now, for sodium, it will be easy to gain 7 electrons, or to lose one electron. What will be easy for this sodium? So, losing one electron is easier. So, it will become 2, 8. So, here your outermost orbit is complete, right? Your octet is complete. So, your losing one electron is more easier for sodium rather than gaining all 7 electrons. What about your chlorine? What will happen? Chlorine will gain one electron because it needs to complete its octet. So if it will gain one electron, then what will happen? It will become Cl minus, which is 288. Now here, so sodium plus and your Cl minus, it will combine and it will form your salt. Your salt is always Na plus and Cl minus. Why Na plus? Because see, why Na plus? Because Na plus and Cl minus. Now Na is doing what? Na is 281, so it is losing electron to become a positive. That's why your sodium will become positive over here, and your chlorine needs 7 electron to complete its octet. So sodium is gaining electron and it's becoming negative. That's why your Na plus is there and Cl minus is there. Now it is easier for you now that metal will lose electron. This is metal which will lose electron, and your chlorine will gain electron to form a anion, which is your negative. Okay, any doubt till here? Any doubt?
No, ma'am.
So clear? Clear? Okay. So next is see. Same thing will happen for magnesium also. It is 2A2. So what will happen? It will lose 2 electrons to complete its octet. So in the outermost orbit, magnesium will have its 8. So it will lose 2 electrons. What about your Cl? Your Cl2H7, so it will gain one electron, because gaining one electron is easier rather than losing all 7 electrons. So it will form what? MgCl2. MgCl2. Okay. Why? This because there will be the cross multiplication, and what will happen? Your 2 electrons of Mg will go to the chlorine. That's why your this formula will become MgCl2. Okay, so this was your reaction between your metals and your non-metals, forming a ionic bond compound. Means from this we understood about electronic configuration, how to gain one electron, how to lose one electron, whether we gain or whether we lose. Now you tell me about phosphorus. Phosphorus is 15. It's 285. So it will gain 3 electrons. Okay. Next is this one. Just a minute. So next is what? This is the properties of ionic compound. Just now we read about ionic compound, no? That metals and non-metals together they are forming something. So these are the properties of that. First is what? First is about their physical nature. So ionic compounds are hard crystalline solids. Why they are crystalline? Because there's an attraction between the negative and a positive ion. Let's say Cl, Na plus and Cl minus. There's happening what? There's an attraction between a positive and a negative ions. So that's why its physical nature is what? They are hard crystalline solids. Next is these compounds have high melting point and boiling point as large amount of energy is required to break there, because if you want to break Na and Cl, then what will happen? We need a large amount of energy. That's why you're high. That's why this thing is having your high melting point as well as your high boiling point. Solubility. These compounds are soluble in water, just like if we take example of a salt, soluble in water, but in insoluble in organic solvents like kerosene. Kerosene is not soluble. Benzene, ether, petrol, all are what? All are non-soluble. Now this is what conduction. These are the good conductor of electricity. Your ionic compound is a good conductor of electricity. Okay. Next. Next is your this occurrence of metal. Shazan, this chapter, no, this one, your periodic classification of elements. This chapter, this one. So this chapter is already removed from a means from CBSE syllabus. This one, periodic classification of elements. Okay, so this is already removed. So from the next class, I'll start this one, carbon and its compound ORG. Understood? Now this is what, I don't know what is happening. This is the occurrence of metals. Now what is the occurrence of metals? Occurrence of metal is that the earth crust is the major source of metals. है ना? Seawater also contains soluble salt. Seawater contains lots of different salts. That's why we do not consume directly water from the seawater, because it is rich in NaCl. First, we need to purify it. So, the elements or compounds which occur naturally in the earth crust are known as minerals. We already know now that in our earth crust there are lots of layers. First is your tectonic plates. After that, your magma, and your rocks. Do you know about that geothermal energy? Anybody know about that geothermal energy? From the earth, from the earth, what happens? Your large amount of steam. Large amount of steam is, steam is um, rising up from that particular circle. Let's say this is your some space in the earth. So from the space, a large amount of steam is going up, and from this steam we can easily generate electricity. How we can generate electricity from this steam? First, this steam will go in a turbine, so this will make my turbine move. Now my turbine is connected with one of the generator, so my what will happen? Because of this turbine, my generator will also move. Now this generator is connected with lots of these types of what do you call that, that tower, electrical tower. So now this will what? Generator will do what? It will pass the current. So these are what? These are the ways to produce electricity. Okay. So occurrence of metals. What is the extraction of metals? The process of the process of obtaining pure metals is from its core is known as the extraction of metals. Means we extract from the earth. What we extract? We extract the pure metals. So that process is known as the extraction of metals. So some metals which are present at the bottom, they are the least reactive metals. Okay, like your gold, silver, these are your copper and silver are also found in the form of your combined state, like your sulfide and your oxide ores. Now these are what? These are the different methods that how we extract the metals. First, method of low reactivity, method of medium reactivity, and method of high reactivity. So, okay, this is what your ore means concentration of ore. This is divided into three types: high, medium, and low. Now, in your high, there will be two steps. Your electrolysis will happen, and then you will get a pure metal. After electrolysis, you will get a pure metal. In this medium one, this is divided into two types. First is your carbonate, second is the sulfide. So for the carbonate, there will be this process, and for your sulfide, there will be a roasting process. But these two, for this also, there will be oxide of metals. After that, your reduction, and after that, you will get a pure metal. And what about your low reactivity? There's four steps. First of all, your simple sulfide ore, your roasting, metal, and refining. Means this thing is equal to this. Okay, so there are three methods to extract the pure metals from the earth. Now, this is also extraction of metals. So, if we will extract, see, this is what cinnamon from air. What we are getting, mercuric oxide and sulfur oxide. So, these metals being less reactive can be obtained by reducing their oxides. If we will reduce this oxide, then we'll get, this is what, this is your mercury oxide, this is your sulfur dioxide. Okay, this is your copper glance. We are getting a copper glance here, copper metal, extraction of metal present at the middle. These are what the metals present at the bottom of the activity series, means that same reactivity one. This is the metals which are present in the middle. So zinc is present in the middle. If zinc will react with your oxygen, which is present in air, if this will roast, then what will happen? You will get a zinc oxide and your sulfur dioxide. What is your next? All things I have already discussed. Now, this is what it is, the process in which the carbonate ore is heated. Means here what will happen? Your carbonate element will heat to form a zinc oxide and your carbon dioxide. And here what will happen? If we will roast it, we'll get a zinc oxide and sulfur dioxide. And if we will do this process, we'll get a zinc oxide and a carbon dioxide. So these are also same. Some amount of heat will also will get. And this is Na plus and electron means 281. So it will lose one electron. So this will form your Na. So this process is known as your reduction. Chlorine is what? Your 17. So it will gain one electron. So it will become 2E minus, will balance this equation. This is your oxidation. Okay, reduction means reducing. Reduction is this is what, electrolytic reduction, the salts of which metals like chloride and molten from the electrolyzed, and this is the reaction of your cathode, of your anode. What is next? Next is this one. See, this is what, this is corrosion. Corrosion we already know now how to prevent corrosion. The very basic method to prevent corrosion is will color, means we'll coat that everything with a black color or a black chromium. Yeah, will color that outside layer. This is what, this is first method is a galvanization method, means it the process of coating iron or steel with a thin layer of zinc. What will happen if, let's say, this is my metal. So here we will coat this metal with a thin layer of zinc. This is your galvanization. Second is your alloying. Alloying means it is the method of improving the property of a metal by mixing a metal with another metal. If we will mix a metal with another metal or with another metal, then we will prevent our metal from corrosion. This is alloying of iron. This is alloying of gold. Will paint, will grease, will oil, or the tin plating, your chromium plating, alloy, and this is what your this is what? The iron pillar near Qutub Minar in Delhi was built in 1600 years ago by the iron workers of India. So they have developed a process which prevented iron from rusting. This is due to the presence of thin layer of magnesium oxide, Fe3O4, on their surface. Its quality of rust resistance, and it has been examined by scientists from all parts of India. The iron pillar is 8 meter high and your weight is 6 tons. So to prevent this, they did what? They did what? They already put this thin layer of your magnesium oxide to prevent your metal from getting corroded. So this all about this chapter. This chapter is already completed. In the next class, I will start with this one. This chapter is big. Okay, everybody understood? Any doubt anywhere?
No, ma'am.
Sure, Roshni.
Ma'am, I know ma'am, there's no doubt. So then, like for the assignment class, so should I like do it now and send it to you, or like how?
Means your assignment timing is from 5, right? And you at that time is not available now.
Yes, ma'am. Yes.
So we need to check that every time you will submit late, or we need to check. I'll let you know.
Okay, ma'am.
Okay. Okay then. Thank you. Bye bye.